Welcome. In this video, I want to talk briefly about solution preparation and dilution, just to help you prepare for the next lab. Please remember to wear appropriate clothing, because today's lab, you could stain your skin or clothing, and I just want you to come prepared for the lab. You'll be putting away all the items you don't need, and then you can use your calculator during this experiment. There'll be one major formula we're using. So let me just pull up a few items here. It's good to know what equipment you'll be using, what instruments, what tools. So make sure you review that. And we'll always start with our pre-lab quiz, and then we'll go into the lesson. So quickly, we'll be preparing. We'll be talking about preparation of a stock solution. It has applications, of course, in nursing, in different fields, in radiology. There are times where you might have to dilute something. You might have to work with the concentration at a certain level. So it's important to know how to do these types of calculations. Now, granted, you're not carrying a pen and paper walking around doing these, but it's just good to be able to double check, right? Because sometimes the computer might take in numbers in a certain way and not give you the number you need. So it's good to have an idea of what to expect with certain calculations. So chemists frequently need to make a chemical solution which is at a given concentration. Molarity is one of the key words for today. Molarity, right? Molarity is very important, and it's the moles of the solute divided by the liters of the solvent. So the moles of solute divided by the liters of solvent. So that is the molarity. There's another word you will learn later or at a different time called molality. That's different. This is molarity. So if you're asked to make 1 molar sodium chloride solution, then you have to add 1 mole, which is 58.44 grams NaCl, to 1 liter of water, right? So that's one way to approach this molarity. So we will be using Kool-Aid powder, trying to show you how this is done. You will have you would have the tool, which will be something that you should have reviewed. You'll be looking at a volumetric flask and knowing how to work with it. So that's part of what you'll be doing in lab. So I want to focus more on the formula to be aware of and just how these calculations work. But the formula that we are focusing on is MI, so the initial molarity times the initial volume is equal to the final molarity times the final volume. This formula is important. So you can use it to find any piece of the puzzle. So if you're asked to find the final concentration of something, then you just divide both sides by the final volume, right? And that will give you the final concentration, the final molarity. So let's keep that in mind. You will have a table, and there's 5 test tubes that you're working with, and you're looking at where you start with a certain concentration and what happens as you move a certain amount of liquid from that test tube to the next test tube to the next test tube, and so on and so forth. So that's part of what you'll be doing in this lab with dilutions. Very important skill to have. So show your work, please. Write down the formula, write down what you've been given, solve for that which you're looking for. So again, in this case, if you're solving for final molarity, you divide both sides by the final volume, and then you just solve. So the final concentration will be the initial concentration times the initial volume times the final volume. So that's just an example of solving for the final concentration. Preparation of solutions of a given molarity. You have a stock solution before dilution, for example, 6 molar hydrochloric acid, and then maybe you add a certain amount of water. So let's say you have 6 molar hydrochloric acid with a certain amount of water, like it has a certain amount of solution of that HCl. And then you add water to it, and it becomes 0.1 molar of HCl. The question then becomes, how much water should I add so that my final concentration is 0.1 molar HCl? These are the times where you would consider using the initial concentration times the initial volume is equal to the final concentration times the final volume. Okay, very good. So there's more examples that we can look at, looking at what initial volumes might be. Again, you can solve for any one of these by dividing by the thing you don't need. That's how we solve for those. So we'll have another table. You have 5 test tubes, and you can calculate the volume. You can calculate the concentration, the final concentration, and so on and so forth. So those are some of the main things we'll be doing in lab. We'll wash our test tubes after. We'll make sure we rinse it 3 times with hot water. We'll rinse it 3 times with deionized water, and then we'll dry them inverted upside down in the test tube rack. So that's what we'll be doing as far as that goes. Please make sure you come ready to show your work. Come ready, prepared with the appropriate clothing for the lab, and everything should go well. So if you have any questions, please do not hesitate to send me an email. Otherwise, I'll see you in lab. Have a wonderful day.